So here we are going to continue, and now we are going to write. We started by a free body diagram, so I'm going to erase everything here, and we are going to put big 2, second paragraph. So you put here Newton's second law. Newton's second law. Okay. So what is second law? It is telling us this is what we are going to do. So the law, what it is telling us. So we're going to write it here, the rule or formula. This is the second law. It is telling us that the force net equal ma. What is the force net? Force net, it is the total force. Total force. You add all the forces. That's what I said. You must know how to add vectors, because the forces are vectors. We have to add them all. Understand? And this is what it is telling us, Mr. Newton. It is telling us you add all the forces, and these forces will give you the acceleration. It is equal ma. It is the acceleration. The F net, it is the total force. This is the formula. And this is the second law of Newton. This is what we call it, Newton's second law. So I'll go to write it here. This is what we call it, Newton's force net. It is the total force. Newton's second law. And what is F net? It is the total force. What is adding? Adding all the forces. F net equal adding all the forces.
So it's M and then A?
Excuse me? M, I'm going to explain you everything. For now, we're going to speak about what is the F net. F net equal adding all the forces. We have to add all the forces. Okay? This is what is net. Where we're going to find the forces? From the free body diagram. Free body diagram. That's what we spend sometimes to find the free body diagram, because it is the free body diagram who will give me all the forces. Mr. Newton tells us, the law of nature, it is like that. You want to find the acceleration, it is easy. Add all the forces and you have them. Now what is m? It is the mass of the object in kilograms. If you have grams, you have to change it to kilograms. The force here, it is in newtons. You know the newtons? The forces, so we spoke about it. The forces are in newtons. And what we have A. The A, it is the acceleration. What is the unit of the acceleration? Meters per second squared. So this is the Newton's second law. It makes here it is telling us why we are accelerating. If you are accelerating, because you are experiencing a net force. Because if there is no net force, there is no acceleration.
So for the total force, that's when you have to draw the free body diagram?
Yes, you have to go to the free body diagram and you have to add all the forces. Understand? We have to add all the forces. Okay?
The forces that you calculated?
Yeah, we're going to take an example and you're going to understand. You are going to understand. You are going to understand. Okay? You understand? Good. So we're going to take an example. We're going to do many examples. But if you understand one, you understand all the others. It's easy. Yeah. Are you okay? Good. So we're going to do here examples. So write example here. I have a surface here. Go to put a surface. Okay, sir. And there is a pack, an object. Okay. And we are pulling this object with a force. We are pulling an object here. We are pulling the object with a force Fa. It is equal 42 newtons forward.
Is this the only formula?
This is the only formula. There is only one. There is only one. Okay. Fa 42 newtons forward. Okay. There is some friction. There is friction here. And the friction, it is pushing the object backward. Yeah, it is affected by a backward force. It is this one, force of friction. It is 12 Newton backward. Understand? So first step, it is 12 Newton backward.
Oh, no,
to 42 Newton forward. The first force that it is pushing forward. Excuse me? Newtons. The 42 Newtons. This is not north. It is Newtons, the unit of the force. Newtons. If it was north, we are going to put it on the bracket. Look, the direction, always we put it on brackets. If it was north, we have to put it on brackets. Do you understand here? So first thing, free body diagram. Free body diagram. We have to put the free body diagram. Okay. First, free body diagram. Okay.
So step one.
This is step one. Always step one. We have to find, because we want to find the acceleration. Here I didn't say, the mass, I didn't give you all the information. The mass is equal to 165 grams. Okay, this is what I did told you. Find the acceleration. Find the mass of the object. Yeah. It is find the acceleration A. Understand? So the first thing that we have to put free body diagram. Okay. So what are the forces on my object? First, we have the Fa, they give it to us, the force of friction, they give it to us, but we have additional forces. What additional forces we have? We have the force of gravity. We said always they are a force for gravity. And we have another force. Which is the other force? The other force, it is the force of normal force. Understand? Good. Now we are going to do the free body diagram. The free body diagram, always the object, it is a dot. And I'm going to put the forces. So I'm going to put a force here. And I'm going to put a force up. I'm going to have a force applied forward, and we have the force backward. This is the normal force. This is the gravitational force. Put the arrows, and they have the force applied in this direction, equal 42 newtons. And we have this force here also. It is the force of friction, equal 12 newtons. Understand? So I have my free body. Now I'm going to write second step. We're going to write the given.
So this is a
Force, normal force, this one. Okay. Yeah. Normally we had to start with the given. This one it is second, but I'm going to put the given in the second step. But normally we have to start by the given before. Yeah, we are going to find them. Yeah. So what is the given? You know how to find the force of gravity? Do you know the formula or not? Okay, we're going to give because there is a formula for that. So the given first give us a mass. The mass it is what? 165 grams. We have to put it as kilograms. 0.165 kilograms. Now, what is the force? Force A, 42 newtons forward. Forward. We have the force friction. It is what? 12 newton backward. We have Fn. This one we don't know the magnitude. We are going to put it Fn without an arrow, and we will put it up. And we have Fg. I'm going to put it here. This one here, we have a formula for Fg. Maybe I'm going to add it. Yeah, you are okay here? Yeah. Fg equal the mass times G, and this one it is down.
so the force of gravity.
Always it is the mass times G. What is G? You remember the G that we used? What is the value of G? We used the G.
9.8.
Good. 9.81 meter per second squared. Okay. This is the acceleration, you remember? Down. So the force of gravity always the mass times G. I'm going to put it here with the forces here, but it is not force Newton. Force of gravitation always equal mass times G down. Mass times G. And we know what is G. So I'm going to pick another page. Are you okay? Okay, I'm going to put it here. All the forces they given. So now the mass equal what? 0.165 kilograms. We have the force applied, 42 newtons forward. We have the force of friction equal what? 12 newton backward.
If it's 9.81, is it negative 9.81?
You put down. Yeah, down. We have the normal force. This one we don't know, so put Fn, and it is up. And we have the force of gravity. We said it is the mass times the G down. Okay?
Can I calculate it?
Yeah, calculated, yeah. So what is the Fg? It is mass 0.165 kilograms times 9.81 meter per second squared. It gives us a Newton, so it gives you how much? I'm going to do it here. 0.165 times 9.81.
Why is it 0.865?
Because this is the mass. We have to convert it to kilograms. The mass always must be kilograms.
Isn't it already in kilograms?
No, it was in grams. So you have to divide it by 1,000 to be kilograms. Okay. Yeah, this one, it gives me 1.62 newtons. This is my Fg down. And now you have to know how to add your forces. So we are going to use the method of the components. Understand? Okay. Okay. So we're going to put the table here. Okay. Third step, add the vectors. Okay. How we're going to add the vectors? We have to go for each one and each direction. So I'm going to put a table here. Here and here. And here we're going to say forces, because forces are vectors. Horizontal, vertical. This is X and this is Y. Okay. You remember how we add vectors? We said we have to find the standard position. You remember? For each force, we have to find the standard position. So I'm going to go back here to that's why we need the free diagram. So what is the standard position? I'm going to do it again here. How to find the standard position for each one. So we're going to put our free body diagram. We have the gravity here, the Fg. We have the Fn, we have the Fa, and we have the Ff here. So this is the Fn, the Fa, all vectors, and this is the F, the force of gravity. So give me here what is here for this force here, what will be the direction? What will be the direction here? What is the standard position here for Fa? What? It is east. What is the direction? What is the standard position? 0 degrees. Because it is in east, and we said this one 0, this one 90 degrees, this one 180 degrees, this one 270 degrees. Remember or not? You know how to find them or not? You know? So what is the standard position of this one?
But there's no also
The values?
yeah, there's no one.
The value, it is 42 newtons.
But don't they have to give like angle?
This is the angle, 0 degrees. This is what I'm speaking
So
about.
they don't give you like an arm?
This is the for the east, the arm, it is collided with the east. For this one here, because this is the east, and this is the vector. The vector, it is on the east. So what is the angle between the east and the vector? They are one on top of the other. So what will be the angle? 0. That's what I put here. When the force it is on the east, the angle is 0 degrees. There is no angle between them. You understand? Okay. So what will be the Newton force here? What will be the direction here? This one will be Fn. We don't know what is the magnitude. We'll put it Fn. And what is the direction here? 90 degrees. Okay. This one here, the force of friction. I'm going to put it a little bit here. It was what we found. We found 162. It will be 162 Newton, and the direction 180 degrees. And for the gravitation, this one 12. It is not 160. 12 newtons. And 180 degrees. And here, what is the force? The gravitation, it is 0. It is 162, I think. And this one, it is the direction 270. You understand? Are you okay or not?
we still need to find the force N.
Yeah, the force N, we can't find it right now. You are going to understand. We can't find it right now. We can't find it. So we're going to write it Fn.
What if it was 360?
Excuse me?
What if it was
360,
360?
it is here.
How would you know if it was 360?
0 and 360 is the same. You can't take 360 or 0. They are the same.
It's the same?
The same. Okay, but we take 0 because 0 it is more elegant than 360. Yeah, 360 degrees, or when you are on east, you can take 0 degrees or 360 degrees. They are the same. Understand? So this is the directions. We find them. Okay, so we did some lessons only to find the standard position. The standard position, it is always from the east. For example, this one from here to here, so it is 90. Now for the other one, this one from here to here in 180, and the last one, it is like this one here, from here to here, it is 270. Okay, you can go also for the other one like this one and make a whole loop. You can take 360 or 0. They are the same.
So for the 270 down?
Now, since you put 270, there is no down, there is no up. Because say the direction, we have the angle that give us the direction. The angle is the direction. The angle is the direction. It is the standard position here. This is the standard position. Standard position. The angle is the position. Is. You have to, if we put down, we don't have to put the angle. If we put the angle, we don't put the angle. We put only one because it is the same. You understand? So now we are going to go to the table here. What is the first force? It is Fa. It is 22 Newton. And the angle here, it was 0. So what we're going to put? 22 times cosine 0. And here 22 times sine 0. Here, if you put the calculation, it gives you 22. Here it will give you 0. Okay, if you use your calculator, you put 22 times cosine 0, it gives you 22 Newton. And here, if you put 22 dot sine 0, it will give you 0 Newton. Do you understand or not? Now we finish it with this first force. The second force now. The force of friction. Go to put it in another color or same color. This one, it is 12 Newton and the angle 180. So here I'm going to put 12 times cosine 180 and here 12 times sine 180. Always the cosine, it is with the horizontal, with the cosine, and here with the sine. So if you put this one to the calculator, put it in the calculator, 12 cosine 180, it gives you what? Put it in your calculator. Are you in the same page or not? Are you? Okay. Yeah, because the force A, it is 22 newtons. The FA, 42. 42, not 22. Yeah, all right. 42. It is 42 here. So it will be 42 here, cosine 0, and it will be 42 sine 0. Okay, 42 here. I take it for 22.
So horizontal
always cosine, and vertical always sine. But when you are using the standard position, you have to use the standard position. Otherwise, you can't use cosine and sine. Standard position. Okay. Okay. So if you find this one, you're going to find minus 12, and this one will be 0 again.
So this one's 42, right?
42, yeah. This one, it is 42 newtons. And the other one, it will be 0 newtons. Okay. Good. So the force of friction It is done. Now we're going to go to the normal force, Fn. Fn, we don't know what is it. We want to put here Fn. So we're going to put, and the direction, we know the direction, it is up, it is 90 degrees. And we're going to put it only Fn times cosine 90 degrees. And here going to put it Fn times sine 90 degrees. Here I'm going to do some algebra. Cosine 90 degrees, it is 0. It gives me Fn times 0. Fn times 0 is 0 because everything times 0 is 0. This one gives me Fn times 1 because sine 1, it is sine 90 degrees is 1. It gives me Fn. So this one will be 0 and this one will be Fn. I don't know what is the Fn because I don't have its value. Okay. Good. Okay. Are you okay?
Yeah. So,
Good.
oh, this is for force, and you don't have to do gravity?
Yeah, we are going to do gravity now. You are starting by gravity. You are going to do gravity now. The force of gravity, Fg.
So for
The direction, it is 270.
So for the normal force, we don't know it?
We don't know it, we're going to put Fn. Look what I did for the normal force. Fn cosine 90 degrees. But I can calculate cosine 90 degrees. This is math here. What is the cosine or 90 degrees of 90 degrees? Cosine 90 degrees? 0. So Fn times 0, it gives me 0 because everything times 0, it is 0. Because 0, it is absorbent. It absorbs everything. 1,000 times 0, 0. Billion times 0, 0. Fn times 0, 0. Understand?
So it's just going to be 0?
It can be 0, this one, because for the cosine.
0n?
No, 0. Because 0 Fn equals 0. Newton, yeah. You put Newton, the unit? Yeah, 0 Newton, yeah. It will be 0 Newton. What about this one here? What is the sign 1? 1. But 1, 1,000 1, 1,000 times 1, it is 1,000. 5 times 1, it is 1. It is 5. So when I time with 1, the 1 goes away and that's it. And it will stay Fn.
Why can't it stay 1?
No. 5 times 1 is going to be what? It doesn't give you 1. Not like 0. 0 times 5 times 0, it gives you.
Then you have to multiply by Fn?
Yes. You have to multiply 1 by Fn. Yeah. You have to multiply 1 by Fn and it will give you Fn in the end.
But it's going to give me 0, like Fn times 0?
No. This one here in the sign.
No, Fn times.
Fn, yeah, it will give you Fn times 0 here. For the x, for the horizontal. But what is Fn times 0? 0. That's why we put it 0. Because everything times 0, it's 0.
But if it's Fn times 1, it's going to stay Fn.
I say Fn. Because a number times 1, it stays the same. But a number times 0, it becomes 0. So we're going to finish this one here. So do the other one here. Fg. So what is Fg? It is 1.62 times cosine 270. And here 1.62 times sine 270. So if you do what is cosine 270, it is 0. This one again, it gives me 0. Okay.
So it's 1.62 and then 270?
Yeah, cosine 270. And here 162 times sine 270, you're going to find minus.
What about here? This part?
What?
This part, like you put 1.62 and then.
The direction, it is 270.
And then brackets, you put 270?
Yeah.
With the gravity?
Yeah. Yeah. This one, it will be minus 1.62 newtons. If you give this one to the calculator, this is what it will give you. Okay, you understand? Now we have to do the total, the force net. What is the force net? It is the total. So we're going to find force net, and we're going to put the total here. So if I put 42 minus 12 plus 0 plus 0, it will give me 42 minus 12. It is 30 Newton. Okay. And here, if I add everything, it gives me 0 plus 0 plus Fn, so it will give me Fn minus plus minus 162 newtons. Okay. This is my table, so I find the force net. Understand? You add them. The force total, we call it force net. The force total, we call it force net. It is the total.
But also Fn is force per Newton.
Repeat again.
The force N.
Fn, it is the Fn.
The normal force.
The normal force, we don't know it. Ah, it is normal force. Ah, don't confuse the N here with net. This is what you are saying? No, this is the force. This is what we put N, and here we put net. We don't have normal. And net, it is, you see, I put net here. I didn't put N.
So what about this N?
This is newtons. Look, the force here, Fn, the N here, it is, put it normal. You can put the word normal if you want. Put the word normal here if you want. And here also I'm going to put the Fn normal. The other big N, it is the newtons.
So
put
N is
newtons. Yeah, we're going to put it like that. Small n normals, and the big N, it is newtons. Yeah, we can put also this one, but if you are confused, put normal as a word, that's it. I'm going to put it small n here. Small n, it is normal, and it is in subtract. Here the newtons, because it is with the value. Okay, but to not confuse, we are going to put it like that. Small n, F small n, it is normal, and the big N, it is newtons.
So this is going to be normal?
The normal, yeah. It is the force normal.
So why is this one Newton?
It is newtons. This is the force. It is the value of the force. Newtons, it is the unit.
But this one we didn't find it yet?
No, we don't find it. Yeah, we don't find the F normal. We don't know it. We don't find it. Now you have to add the vectors. Add the vectors. Add your column, the horizontal column. Add them all. Good. Plus 0 plus 0, which will give you 30. Don't, yeah, it's all right. It gives you what? 30 newtons. So do the same for the horizontal, the vertical column. Do the same for the vertical column. Plus, good. Plus Fn. Don't forget this one also. You have to add everything. Yeah, we have it here. Plus, you add 0 plus 0 plus Fn plus minus 162. But 0 plus 0, I didn't put it because 0 plus 0, it is 0. It changes nothing. Understand? And do some algebra here. 0 plus 0, it gives you what? They will cancel. And you are going to force net, force normal, minus, plus minus, it is what? Yeah. Understand? Okay. Okay. And now, this is the third step. We added the vectors. Now the fourth step. Apply. I think there is no way. Apply. Newton's second law. Newton's second law. So how are we going to apply the second law? Mr. Newton, it is telling us that the force net equal the mass of the object times the acceleration of the object. Okay. And how we're going to apply it, it is like here. Because the acceleration has two components, the acceleration, so we're going to put it here. The force net horizontal equal mass, or horizontal equal the mass A horizontal. And we have the force net vertical equal the mass acceleration vertical. Okay. This is the rules. Always the force. This is another way to write the Newton's formula. Force net horizontal equal mass A horizontal. Force net vertical equal M mass A vertical.
So
They are the same. Yeah.
times A
Yeah.
horizontal.
Horizontal. And the force net vertical, you put it, and the force net. So we are going to apply what we said here. Okay. Force net vertical equal the mass, the acceleration vertical. Okay. So what is the force net horizontal from our table? It is 30 newtons. What is the force net horizontal? 30 newtons. So I'm going to put it here, 30 newtons equal the mass. What is the mass? So this one will give me this one here. So I'm going to put it properly that you can understand. So I'm going to put it here. Find A horizontal. And I'm going to apply this force. Force net H. Now when you say H, it is horizontal. Or I'm going to be confused. Force net horizontal. Sometimes we put X. I'm going to put X. Because when we put X, it is horizontal. When we put Y, it is vertical. Are you going to be okay or not?
No, I'll just leave it
Like
like that.
that. Okay. We're going to leave it like that. So we're going to put force net horizontal equal M A horizontal. Are you okay now? What is the force net horizontal? 30 newtons equal. What is the mass? 0.165 kilograms times the acceleration horizontal that we are looking for. So to find the acceleration horizontal, I have to divide by 0.165 kilograms, and I will divide by 0.165 kilograms. Okay. And now the acceleration horizontal equal, going to make the division, 30 divide 0.165. It gives me 181 kilograms, 30 newtons. Yeah, 181. Going to see, goes too much, 181. Yeah, 181 dot uh, dot 8 meter per second square. For the significant digit, we're going to take 182 meter per second square. Are you okay or not? You understand what we did? Kilograms A horizontal times A horizontal. So we have to solve for A horizontal. Don't put an arrow for horizontal. I didn't put rows of horizontals. We don't put arrows. You can if you want, but we don't. The same here, the forces, horizontal. We don't put arrows for horizontal and vertical, we don't. But with force net, yeah. Because the force net, it is merging the horizontal and the vertical. You understand? So you divide, and you will get 182 meters per second square. Yeah, you have to solve.
Bring it to the other side.
Yes, what you're going to do to bring it to the other side.
Divide.
Divide. Yeah. Why you have to divide? Which one tells you to divide? Because we have multiplication. And the opposite of multiplying, it is dividing. So you have to divide. Okay? So if you divide, you are going to find this one. You are going to do the calculation later. So put as divided by 0.165 kilograms. It will give you 182 meters per second. 182. Okay? So what about now vertical? I'm going to erase everything here. Or I'm going to put it in another page.
So,
Yeah.
you have to divide a horizontal by 1 0.
No. You have to divide by this one to find a horizontal. That's it.
Just divide these two.
These two. Okay. So last thing that we have to do. So follow here, and you're going to continue later. Here we're going to find the vertical. A vertical. Find a vertical. The formula, it is what? Force net vertical equal the mass times A vertical. Okay, good. And you round it to 182. 182 meter per second. 182 meter per second square. Now we're going to find a vertical. What is the formula? F net vertical equal M A vertical. Okay. What we found for F net vertical? Can you show me what you find? We found it was Fn. F normal. Yeah. Minus 1.62 newtons. It gives me what? M. The mass, what is the mass? 0.165 kilograms times a vertical. Here we have to do some physics. Until now we did only mathematics. Solve the add vectors, apply the law. We did the law, the Newton, it is physics. But here we're going to continue to do some physics. So look here. What is our exercise? It was here. Where was it? This one here. Okay. So look here. Okay. The object, it is moving horizontally or vertically? Is it moving vertically? No, it is not. There is no way that I am pulling it horizontally, I am pulling it forward. There is no way that the object is moving vertically. It is not going up. If it is not moving vertically, what will be the acceleration vertically? Is he accelerating vertically? So what will be the acceleration? If it is not moving vertically, what will be the acceleration? It is not moving vertically. What will be the acceleration? If it is not moving vertically, so what will be the acceleration? The vertical acceleration. It will be 0. It is not moving vertically. So it will be 0. Okay? That's why we have to, when we see the motion, you have to make sure in which direction the motion is. Okay? This one here, we're going to write it here. A vertical equals 0. Because the object is not moving vertically. If an object is not moving in some direction, the acceleration on that direction, it is 0. If the object is not moving horizontally, the acceleration is 0. Okay, if it is not moving vertically, it is 0. That's why an object who is standing still, what is the acceleration of an object standing still? 0. It is not moving vertically, it is not moving horizontally, it is standing still. Its acceleration is 0. Okay, so now we have the acceleration. Okay, so we find the acceleration because the vertical acceleration is 0. So the acceleration, this is what we was looking for. The acceleration of the object is 180 meters per second forward. Okay, because it is positive, it is forward, so it is forward, and that's it. Okay, so we find the acceleration. Here you can put it here, we didn't put it, but you can put it when you find it here horizontal, because it is positive, it is forward. Same here, it is forward because it is positive, forward. Okay, you understand?
A equals 0?
No, not A equals 0. A equal 182. The 180 is equal 0, it is the vertical, not the horizontal. The horizontal, how much we found for the horizontal? 180. That's what we are going to put it. We'll put it A equal 182 meters per second forward, horizontally.
How do you know? Is it always going to equal 0?
Which one? Vertical. If it doesn't move vertically, that's why you have to take to look at your situation. In my situation here, we say it here. The situation tell me that it will be 0. Here, this one here. The object, it is moving forward or backward. It is not moving up and down. So vertically, it will be 0. But horizontally, yes, there is acceleration because it is moving horizontally. Do you understand or not? You are confused? Confused by what?
So if it was horizontal,
If
it wasn't moving horizontal,
it will be 0 also. The acceleration, horizontal acceleration.
if it's moving vertical, then it would be 0.
Horizontal, and it will be no 0 for the vertical. Okay?
So what do you have to say for this?
Yeah, you say the acceleration, it is what we find. This is what you have to say. This is what I said. I put it here. This is the answer. It is the fifth answer, the fifth step. The acceleration of the object is a 182 meters per second horizontally forward.
So a vertical
Equals 0. We're going to, yeah, it is vertically equals 0. Okay. And so we have only horizontal acceleration. We're going to write it. A equal 182 meters per second. We're going to go, you can write horizontal if you want, but it is, there is no horizontal vertical. There is only one direction. Okay.
Can you like calculate it still?
Calculate what?
Vertical?
The vertical is 0.
If you calculate it, you'll get 0?
0, yeah. It is 0. It is 0. That's why. If you calculate it, it is 0. Because the object is not moving upward. Are you okay?
Yeah.
So I'm going to stop the video here, and that's